let's say they pour the material into the syringe. Okay. Then what they do is they see bubbles. So they put on this machine, they turn it on, this machine will spin, and move the bubble to a place where they can just remove it. So this is called a centrifuge machine.
Actually, for this system and the ILS system, most of the software structure is the same. Maybe this process we don't need the conveyor, so we just disable some of the conveyor function.
Okay.
Most of the feature is the same.
They are using the same software.
Yeah, the same software. Yeah. Actually, this is our fast interface. If we switch on the machine, the user will see this interface. And then we have two process. Normally for the maintenance, we just do for the system setup. Profile editor, we do the program and do the some testing. After that, the operator can use the production run mode to run the production. Actually, I will start from the maintenance pass. Then you just press OK. Maybe you need to key in some passwords. Maintenance and profile editor, we can set the password, not the operator to allow to use these two processes. If you run every program, the system will do the homing. This will call the home. The user cannot change. For this interface, the robot home means this is the hard home, also the hard home. If you robot home is the hard home. System home we call the parking position. The user may need the one position before they start, or before they start to run the application and finish the application. The machine should be go to standby position. We call the system home also the standby position. Daytime position means daytime position for needed calibration process. Needed calibration process we can set based on the bottom camera position. We can set this position. For example, we set the user. If user know the position, they just key in and then they can save. They can press save button. If the user don't know the actual position, maybe they can use the each on process that machine to move to that position. For example, maybe we can set this position to parking position. We just and then just press save. Purging position means most of the process they may need the purging process. Sometimes we can say cleaning process or purging process. Maybe they have one cup, or they can put it anywhere. So they want to do the purging process. So they also can define the purging position based on which area they want to do the cleaning process or purging process. system move height means when the machine move from one position to another position, they may need the height, the system height. So they may need to set the system height position. This position, if you this position can this position.
Can I say is something like 1 point dispense,
yeah, they have to move,
then move up,
move up,
that
get
height,
the
right?
height, yeah.
So I go to another point,
Yeah.
then move up, another
No.
No.
Actually, this if you want to do the two-point process, maybe you just need the just small amount of distance. So you mostly that part we can do on the programming mode.
Okay.
This system height mostly for the whole process.
Finish.
Not the finished process for.
Or go to a far point.
Not the far point. Mostly, we set Z height for all the component safety region. Because if you set the height, system move height.
So there's a high limit, right? So that you do not go beyond that. Is there something like a safety limit switch?
Not the safety limit. Because the safety limit switch, we have a hard limit and soft limit you can set.
Okay.
This one, not the limit position. This one just for the whatever the system. I can show you. Actually, we set the minus. Actually, we set the -4 position. If we let machine to move patch position, system will move to the depth height and then move to the depth position. For example, you will see if you move the system. I will show you.
Okay, basically that is a system setting such that any movement of the robot as a whole, not the robotic movement during dispensing. Any of the system movement means moving from one point to another point. That is the height that you move to.
It's not for dispensing height.
Not for dispensing height. Yeah.
It's for any other movement except the dispensing.
Then why is -4? -7 for?
It can actually go below the. That's why in the future we will take up this.
We don't have, yeah.
Because actually this negative.
Usually this negative is
It can go below the reference.
You can set
position.
any position.
Okay.
So in the future, I will talk to them is that we will take out this negative. In other words, we define the zero as a really zero. Absolutely. Right now the zero setting is such that you set a zero, you still can go below and above. So that's why you have a negative positive. So I think this is a little bit confusing for customers. So eventually we'll define the zero as a zero. They say no more negative. So that is easier, straightforward.
Actually, because actually our system, all the movement, if the machine move to that direction, will be the positive. One movement, this direction will be the positive. Z move from the zero and then move down, always the positive value.
Oh, move down is
Move down is positive value.
move up is negative.
I think so I will show the move. If you see, if I move down, the machine is coming down. This value is increasing. This one. The soft limit, user can set the soft limit. Soft limit mostly for the safety purpose. Sometimes hardware will be failure, maybe the sensor broken or something, so the machine will hit the stopper, overshoot or this condition. So we can set the soft limit. mostly we set the soft limit within less than the within the hardware limit position.
Within the hardware?
Hard limit position.
Yeah, basically the soft limit is such that you can set it anywhere. Let's say for example your board is that's 300 by 300, right? Then you have a travel distance of 400 or 600. So the robot directly can move all the way to 600, and then and when you hit the 600, it does an error. So basically, what it can do is it allows you to set a soft limit, let's say 400. So it doesn't need to travel until 600 before it gives you an error.
Because our part is only 300.
Correct. So if you go to 400, it will give you an error.
Machine will stop.
The full length of the
Not full length.
These are all safety measures.
Yeah.
Actually, for the sake of time, maybe we quickly go through not so detailed.
Okay.
Then we do the dispensing. Because
Okay. Yeah,
Okay,
yes.
okay.
Don't go through such a detail.
Okay.
That's later.
Okay. And then after we set all the position, if our system is currently we use the camera system, so we need to do for the camera process. So if you want to use the camera, maybe you just press the vision calibration. Vision calibration process we can do two parts: the needle calibration and fiduciary calibration. The needle calibration and fiduciary calibration. Needle calibration mostly we use the needle calibration to calculate the needle offset. Whenever the user change the needle, and then they have to do the needle calibration, so we can compensate what's the needle between the reference needle and the current needle, what's the difference, so software can compensate back the correct position. Actually, the maintenance process are mostly for to teach the reference position. All this data will be used on the production and profile data.
So it's doing calibration now?
No. This doing the calibration. Our needle calibration process, the first thing, the machine will move down and then let the laser to detect the needle height first, and then we use the camera to do the XY process.
So but there's nothing for automatic changing needle, right?
No.
All needle must be changed by manually, right?
Yeah. Actually,
If we didn't change the needle, so we don't need to do the needle calibrations, right?
Yeah, I think so. If you do the different application, you may need to do this process because if different application they will use a different needle, so you have to do this process.
So now he's still doing the calibration or already done?
This one we just finished for the Z process. I will show you how to do the XY.
I think no need. So you do all this thing, you will not time. You need to go off at 12 o'clock. So you quickly go through and don't go to all this detail. This detail later on. You can this are all equipment training later on. Go to a very brief description of the features. Don't explain detail. Then go on to demonstrate the dispensing.
Okay.
Actually, this is your camera, right?
There is a fiduciary camera. There's another camera inside that does the what we call needle calibration.
No wonder. So which means the PCB box is actually inside.
No. This round hole is actually a needle.
This one the needle tip.
So basically, we are trying to recognize the position of the needle. Every time you change, the needle position will be different. So we are trying to recognize the position compensate for position such that when you do a dispensing, you go back to the original position. For a desktop robot, this is optional.
Yeah,
The
this one.
customer may not need this. If they don't want this, they can don't take this because this is added cost.
It means a camera. Or
Yeah.
Inside there's a camera and a laser. So they does not need to take this option for a desktop robot.
But actually, if without camera, would it be very difficult for them to?
Teaching.
No, there's two ways to do it. We actually have another process whereby we can use the top to actually do the calibration also. The top camera to do the calibration, or alternatively, even if we don't use the top camera, you can use a mechanical method to do the what we call needle calibration.
Yeah.
So that is the cheapest. The mechanical method is the cheapest.
But what I mean, if when come to the dispensing, when you need to dispense, because the visible part is so tiny, right? So how can I know that that is the area that I really need to dispense? If
You basically have a master board whereby you do all the programming already. The position, you reposition everything, key inside already. Because for example, you have the X 00X 111213, all the position is very careful. So once you enter the position, every time the robot moves, you will go back to the same position. But when you change the needle, right, even though the robot goes to this position, the needle will be like that.
Yeah.
Okay, the needle will be like that. So even if you go to the same position, when it dispense, it may dispense here rather than here. So that process will make sure that if the needle is like that, when the robot dispense, the robot will move this way such that it dispenses at the same position. Sharon, let's quickly go through and do the
Profile editor, this part for the programming mode. Actually, the programming mode also this part. If you do the teaching, we have to use. So you can choose the user want to do the dot or line, or they want to draw the circle or the arc. And then whether they want to draw the rectangle, they can choose what kind of process they want to do. Do I need to go through detail or
no.
Okay, I just
Go
upload
direct to the
my sample program.
sample program.
Actually, I do the sample program for dotting process and drawing the line rectangle process. Actually, I do the program dotting process. I use the array dotting. If you know the pitch for the two position, we can do the array process. So you don't need to teach every point. You just teach the first point, and then you just key in the deviation value, x1 deviation value. So you can the system will do the automatically array. So I just do the simple program. If you see, you select here, all the dot related parameter will be shown here. So this one, the dot, you can set the dispense time. This is the retract delay. Sometimes after finish dispensing, you can set the delay time. If you set, sometimes based on your application and material, if you set the delay time, material dispensing, and you will get the better dot. Sometimes the material, based on the material flow, you may need to set a retract delay. Currently, you say the move height and retract means if you set the retract height and move height, machine will do the retract a little bit, not the based on the system height. They will not move from the system height. They just move based on the retract height and move height. This is a try run.
So for
This one, the docking array.
for this run, will allow you to do to do a dry run.
This is the
The material are not activated.
Test run.
Okay, this one is the test run. Because I saw that I changed the meter, maybe the height is very low, so I may need to offset it here. So I will try to do the patching first. Patching 0.2.
Normally before you do the first stop, you want to make sure that the needle, everything here is filled up. Then you start. So that's why you have to do a patch to fill up the hole. Not the first stop is usually empty. This is not supposed to be leaking. It's a bit leaky.
What is this adjustment?
This one, the air pressure for the TV.
So this system has an inbuilt dispenser. So you don't need to buy an external dispenser. So this is what we call a time pressure method. So this is set the pressure, this set the time.
I'll try to run the work line. Let's see this.
This is actually a very simple design. Normally application is also simple. So this is very simple. Just to show you. So this is basically how it's being done. But like I say, this is a simple thing. You know, when it comes to application, it's not so simple. Yeah.
I think for if you this one for the programming mode, user can use this interface to do all the programming, all the pattern file. If everything finished, you can just open the disk interface, let operator to run the whole process. They just can choose the program.
Okay, no problem.
Maybe this part not because I just want to show the production run first.
stop it because otherwise it will overlap this one. Okay. So this is simple demo. This is what
But when doing the programming that time, right? Like what Miss Lee said, they will have a standard PCB board put there, and then they will just program it.
So you just put board there, whatever you want to do, you just program on it. Then after that, it's save. So let's say the important thing is this thing here. When you do a calibration or whatever, whether you want a calibration, auto calibration, you want manual calibration, this thing that is optional for static desktop. That's why desktop is you don't consider an automated system; it's a semi-automated.
Mr. Lea, what's the use of that camera then?
This is the fiducial for fiducial alignment. In other words, let's say every time you put a board on it, the board may not always be in the same position. So this one is to recognize the position of the board, board, compensate it such that you always display at the location you want on the board. Not the robot itself does not go back to the same position, but you make sure that it dispense on the same location on the board.
Okay, I understand. Yes. Okay. Yeah, basically okay.
Go for fast.
So this one I will use connect here. So I will show the driver.
Okay. Turn on the light.
This is also doing the same concept, it's just that this is inline line.
Yeah. Maybe we don't need to. We can see the camera. So everything I will just align it.
Okay.
Actually, all the interface quite similar to the Technodigm tabletop one. Only different things. This system they also have an option. They want to use the single valve or dual valve. They can have an option because this system will built for the dual head. So user can do the based on their application, they can choose single head or dual head because this system is dual head one.
Let's see the run.
Okay. Actually, I will show you the production line because maintenance and editor process mostly the same. Most of the program is the same. I will release the application. Okay. I will show you the demo.
This is your fixed configure section.
Yeah.
This one is adjustable.
Yeah, this one is this is what they call a motorized
Actually, the different things they only have a conveyor mode. If this the inline system, if you want to use the conveyor system, you have to select enable conveyor process, and then you have to press the auto process. And I will show you the if I put the conveyor system. And then if we just I will show you the camera mode one. Yeah, this one the fiducial process. I just need the dot to because whenever the board coming, they will compensate the faster. Whether the board is have an offset orientation, the system will compensate, and then they will move it back to correct position.
So can you show one more time?
Okay.
Okay, excellent.
Okay.
Yeah, do it one more. Yeah.
This one will auto. If you just press one time, if the operator just put the board, the system will do it automatically. Yeah. actually the conveyor itself they have a tolerance, so maybe fiducial calibration process mostly will be used on the this kind of process. The system can compensate the port orientation and offset.
Okay, good. One more, I will focus in here.
Okay, and then I will. Okay.
So between the camera and the needle will not go
Different process.
at the same time, right?
Okay, I will show you.
Just now you only show the camera, right? Camera will run to identify the positions.
Yes.
Then the needle will come over to look at this time.
Yes.
They will run together.
System will do the full conversation.
What do you mean by run together? I mean the camera and then the needle.
The camera work the leader sensing.
No.
No, no.
Because without knowing the system,
Yeah.
you cannot dispense. You must find out the position first.
Yeah.
You run to those mountains together, you can.
Can put one more time and see the thing.
Okay. Okay.
Yeah.
I don't know.
Okay.
Here.
Yeah.
Okay. I just.
So which means the actual process will be the camera is running to identify the position.
Yeah.
And after it, then after that, then the needle.
Finish the program.
Normally, this one will not be hanging loosely like this one, right?
Yeah, I have to use the strings, and then this one I have to give the pressure.
Ah, okay.
Yeah, this one for something like that.
Yeah, string, yeah, okay.
Yeah, we have to use the material because
Yeah.
this one just for the bath, so we have to use the material, and then we have to give the pressure.
Yeah, yes,
That's quite
yes.
quite similar to here.
Show the jet.
Yeah, I do the.
Okay.
No. Actually, this one, both.
Both.
Yeah, both. This one and then we change these two.
This is supposed to be the speed of the jetting.
Between the first process is run and the second process is jetting.
So jetting is about, so you can compare the speed of this part versus the speed of the rod easily. This is very fast. Just what comes to Germany is evaporates here.
picture, I just run the same process.
Anything?
Just so you cannot see. Yeah.
Wrap it up already.
Yeah, because I just put the dispense time 0.002 millisecond.
Probably wrap it up because they're using solvent, so once you
Okay.
So anyway,
Yeah,
sure.
we got some idea
yeah,
how it works.
I was hoping you would do a much better one. Anyway,
Yeah.
so this is the
This one just IPA, just a solvent.
Oh no. You mean usually it's actually fitting like this
No, you
to hold it? You mean the way we hold the needle?
needle holder.
No. You mean usually we actually rest this syringe in this position?
yeah, it's okay.
Okay.
No problem.
Alright. So can I have one more video? Can I hide this at the back so that I don't see it dangling? Can you run once more?
Okay.
Yeah. So I get a better picture to produce. Excellent.
At least for this process, you will see the machine is not because we didn't do the conversion. I just do two different. So if you didn't do the fiducial calculation process, maybe if you on the dot, the system cannot compensate. The previous program, I just do the single dot if and then let the system do the compensation.
Okay, excellent. Thank you. Yeah. Okay, done. Okay, yes.
Or put the plastic here is partly because when we use it, the spring typically it's not so clean. So we just want to keep the machine clean, so we put this thing.
Yeah.
So this is a head, but at the same time, this is the spring head. But at the same time, this head is not fine. We are going to change off. Okay. In other words, we are going to obsolete this head. Then we are doing another one over there. So we are redeveloping the head to be something like that, okay, where it's more robust and can withstand higher speed. Okay. So, but at this moment, it's being done, finished. We have to integrate it in to do it again. Okay. So it's the same. You look at it, the same. The platform is the same, but there's a little bit of difference inside in the sense that we have all this kind of stuff. Okay. So because the spraying system needs a different thing. So this is a coating machine. We use it to run customers' part.
Okay. So for this spraying, who is using it for the moment?
Okay. For example, like in Thailand, we have those people that I say that is dealing with automotive electronics. So companies like SVI. I don't know whether you know SVI. Then we have.
This automotive, right? SVI.
Correct.
Automotive
They
electronics.
actually a subcon, but they also have they also have other customer, not automotive, but they are also serving automotive.
Okay. What they spray on actually?
PCB.
PC board. Okay.
Yeah, PCB board.
All right.
Mostly a lot of that PCB board. Okay, in
Protective coating, right?
correct. For example, in Penang, this company called SMT. This is SMT, right?
Yes.
Yeah. They are using spray coating also. In Penang.
Okay.
So yeah, we sold quite a few of these machines to Thailand for spray coating.
Okay.
So this is spray coating. And this is one of our, this UV I'll talk to you today.
Yeah.
That's how you see that one is the first generation, this is the second generation. We build it and we don't know what to do. Then we go on to the next model.
Second generation is not using, they're selling the third generation.
So we actually develop from one to another.
Yeah.
But this one we actually can use it still. We are going to retrofit it such that we will give it to someone to do evaluation.
Okay.
So you can see a lot of our tabletop configuration
Yeah.
that we built from one to another. So this is our latest one. This is our latest one. It's a lower cost system from the one you see below. Okay. So probably we are going to finish this off and then we're going to push this up. As a lower cost system to what we have below.
Okay.
The system below probably costs with a granite base and probably costs about 30,000+.
This is a granite base.
This is metal. Okay. So this one will probably cost much less.
Okay.
So it's something. So what I want to show you also is these are some of the UV developments that we talked about.
Okay.
So some of the valves, the physical valves I can show you to you.
Okay.
These are the physical valves.
Yeah.
You can see this is basically material in air to control the, and this is to control the movement height of the piston. And you adjust this, you adjust the volume coming out.
Okay.
So these are the valves. This is what you see below just now. This is our workhorse actually. Our very first valve, and we sell until now is still very sellable. It's a very general valve. You can use it for almost anything.
Okay.
So it's a very quite versatile valve. Let's see what we have here. Okay. And this is another one. This is the SPV 100. Okay. Probably the snuff valve that I told you already. We have a set of pull back. These are the controllers. These are the controller. These things like SVC something. These are the controllers to go with the valve. So basically, all this equipment you see, they have the I/O, foot pedal, everything. This all can be integrated into automatic system. So you can sell it to automation company or customer can use it to put together with the robots and stuff. This one is this is the valve controller. Okay. This is the valve controller. Basically, you just connect to any of this. Okay. And you can control the valve. Like what I say is customer need not buy this if they can have their own pneumatics. But if they want to go to trouble of having their pneumatics, they can simply buy this, plug in whatever they want to plug in, and they can run. Digital dispenser. So correct. It's a digital tag. That's about it. So it's actually all these are very simple things. This is how a parastatic can look like. This is another version.
Okay.
So you can set a lot of stuff: vacuum, shot size, rotation angle, speed. There's a lot to set.
Yeah.
So once you get used to it, our customer normally will just play around with it to get the parameters they want. Normally for this, when we sell this, typically we don't. I wouldn't say provide no service, but normally the customer will determine their own parameters. Sometimes the customer will say, okay, I send you the stuff. You will make sure that this equipment works, right? So we will do for them. We will check, and if it works, probably we can also send to them the parameters that we set, so the customer can start with the parameters that. This is the AD2000. This is the simplest one. So this is the simplest one.
Okay.
So you just timer. This is timer. This is on off. This is set the timing. This is set the timing. Pressure. Plug in. This is a vacuum suck bag. I didn't explain this vacuum suck bag. Okay, this vacuum suck bag is basically to prevent leaking. Okay, it's a features that help you to pull back the material. Okay, so after we pressurize the syringe, and then when we stop, we cut off the air, right? Then this will kick in. This is a vacuum. This will kick in, and the vacuum will pull. It will create a vacuum to pull back the material.
You are continuously pulling at a constant vacuum?
Depend on the timing.
Okay.
If the time is long enough, the vacuum can be constant. But if the time is very short, then it has no time to reach the set value. But
okay.
it all depends on how much the customer did it.
Okay.
This one, one of the big difference that we have here, and why also makes it a little bit more expensive, is we actually have a true vacuum transducer inside. A true vacuum transducer inside. Many products they have some kind of vacuum suction. Okay, but those usually do not give you very effective. It gives you some suction, but not as good. So ours, we are using one from a company called Pisco. A vacuum transducer that is really used in the industry. So
I thought a vacuum transducer is only acting as a sensor.
no, this one is to create
a vacuum.
Venturi effect. We create a Venturi effect.
Oh, okay. All right.
We say I stopped because we are using this. This kind of display, so customer doesn't quite like it. So we stop this. We're going to change this.
Okay.
So this one it has everything that's digital. Even the everything digital. And this can create we can create a feedback loop using this.
Okay.
So these are simple valves and controllers that we have. So the rest are probably UV stuff, which we'll talk about tomorrow.
Sure. Is your engineer doing testing?
This is automation. He's doing some testing. He assembled some valves, so he has to test the valves to make sure there's no leak.
Okay. Can I just have a look? So he's now testing the valve.
We're using water to test it.
Yeah. Okay.
Make sure no leak, no nothing. Leak everything he has to take care of it.
Okay. Yeah. Okay. What is this micrometers for actually? This part.
To adjust the volume.
Ah.
The volume, you can adjust the
yeah.
volume.
Okay. Yeah.
You just press on. So this is like, and there's a timer. So basically after that, the timer expires, just switch off.
Okay.
There's no filter in here. You see the light. It's almost white.
Yeah.
So in other words, whatever UV spectrum all that go through. That's why you see white. But if there's a filter,
This is full range.
yeah. If there's a filter in it, you see blue.
Okay.
So
The keypad is for setting time.
yeah, programs and you can set the percentage of the what you call the light coming on intensity, all these things. Or do some setting. So it's actually very simple. Once you turn it on, you set your timing or whatever, the opening, whether the shutter is going to be full or hard or whatever. And then you just press the button and start.
So what's the use of ignition?
Ignition is to ignite the lamp. So when you turn on the system will be on, but the lamp will not turn on. Okay. So when you're ready, then you press that one, then the lamp will ignite.
Okay. Ignite for a period of time that we have set.
Ignite, the lamp will turn on.
Okay.
The lamp is always on.
The lamp is always on, or not the UV. Only when you need the UV, only then we press the ignite.
No. The lamp is always on. The lamp is the UV already. The lamp is the one generating UV. When we start, we are controlling the shutter.
Okay.
So if the shutter is open, the light will go through this one.
Which means now, even though we cannot see the lamp, but internally the lamp is actually
It's
on.
on. Yeah.
Okay.
You don't on off the lamp.
Yeah. Correct.
You don't on off the lamp. The lamp is always on.
Then the ignition means
Turn on the lamp.
turn on the lamp.
Yeah, turn the light.
Oh, by pressing this start, we actually start open the shutter.
Yes.
Okay. Alright.
This start only controls the shutter.
Okay, I understand.
It doesn't control the lamp.
Yeah. Okay. Okay, I understand.
So now if I press the ignition, the lamp will off. Or on.
If you press ignition, then nothing happens. Off. Okay. Yeah.
Oh, okay.
So which means if we didn't press the ignition, the lamp will always on.
No. Okay. The operation is like that. When I power on, okay, the fan will turn on. The fan, you can hear the fan coming on. Okay. There's nothing else happen. The lamp does not turn on. Okay. When I want the lamp to turn on, I have to press the ignition. Then the lamp will turn on.
Okay.
Once the lamp turns on, that's it. Then you set your whatever setting you want. So after you do whatever setting you want, you can start to use it by pressing start.
But just now I saw you press start already, then the light is coming.
Yeah, because it's already on.
Yeah.
He already on the lamp.
So
Already.
start basically on the shutter. Open the shutter.
Open the shutter.
Ah.
Yes. The lamp is already on.
Yeah.
Before we came, he already on it.
Okay.
So start is on. You want to switch off, I think you press again. If not, you let the timer expire. If not, you just let the timer expire.
Okay.
So either you do this or you can connect a foot pedal lah.
Okay.
And then you can control using a foot pedal.
Yeah. Okay. Yeah. So this one controlling the intensity in terms of percentage as well as the timer.
Yeah. You can
Yeah.
control it.
Okay.
I can do something.
Cái mình không thể cầm cái máy ignition.
Off.
即係一擺 off 一擺 on 一擺 off 一擺 on。
Yeah，即係 ignition 咧係 on off 佢嘅燈。呢個咧佢話好似 camera 咁樣有個 shutter 就算嗰個70%先係咪？佢都係 by controlling 佢嘅 shutter。
佢 off 咗嗰隻燈。就算我撳 start 佢都冇燈着㗎啦。
係啦，應該係啊。 This a lamp holder. This pole holder. This a device to hold it. No, no.
It's something else that we just hold it.
Ah, okay.
This is a material from a customer. So basically, just cure it. What we do is, this is quite thick, so it takes a longer time.
So the distance will also affect the distance.
Yes, the distance will affect the intensity. So whether it cure or not, I don't know, because I didn't determine the parameter. But let's say we touch it, this is coming. But it doesn't mean it's fully cured yet.
Maybe internal still.
Maybe a little bit, we don't know. I guess I just don't know. So there is.
Okay.
Oh, that's right. This is fully opaque packaging.
So the test unit we tested.
Yeah. Yes.
Actually, we started to build already. Then we found some problems, so we hold it.
Yeah.
So it's very straightforward and easy to use.
Yeah.
We always make one set of the equipment that we design.
Yeah.
Put it somewhere. So the main thing is actually this thing. Okay, this is the one that does the metering. Okay. So the main thing is this guy. So this guy just put your material by gravity, it flows down to here. So this is the one where we put in the hose here. So this is the simplest equipment that we came out with.
Okay.
This is the pneumatic one. It's like that. Then this one is the gear type. This one is a gear type. So the gears are inside here. So this is the other, what you call a standard system that we built. So this tree is a standard system.
Okay.
So these three are for customers that we can meet easily type. Then we say, okay, then just take this, just take this.
Not critical requirement.
Then we don't need to go through the customization and this kind of stuff.
Okay.
And it will be more cost effective also. So these are the mixers that we have. The other one, customized one, of course, we don't have it.
So which means the tank you put here.
This is the tank itself. This is the tank itself.
So this just open all things, all the materials inside. Oh, so this comes
Correct. It's like dispenser. Put the stuff here, press the button, it comes up. So
Isn't it that this is for mixing dispenser?
Yeah, makes sense.
Those is actually just one material dispenser. The general one.
Yeah, those are single part, two part. So these are the mixers. This one is a little bit more complicated.
In the most is 2 in the market. Any mixer more than 2?
Yeah, 3.
The max is 3.
Not say the max, there are 4 also, but as you go,
It's too complicated.
It's not say too complicated. Very few people need 3, or even fewer people need 4. So there's no point to develop all those things where you don't sell one for many years. Yeah. Recently we have one customer from JB come to us. Many years ago, we sell them one system, mixing system, many years ago, and that mixing system is not from us, from Korea, the company that. This one we incorporate our UV sensors in. Okay? We incorporate our UV sensor in. So there's supposed to be a display here that shows you the UV output. Okay, but we found out that the electrical component we use is affected very much by the heat generated. So the value come out is not right.
Okay.
The sensor is okay, but the value come out is not right. So we take it out, and one of the guys is now redesigning the component to be away from the sensor. So what we're going to do is we're going to mount the sensor here, but the electronic components will be further away, so it's not affected by the heat. So this is the tabletop model.
Okay.
This is a tabletop model. And with a UV output. Not many conveyor system, tabletop conveyor system have UV output. Not many, because although it's very simple to put a sensor, it's not simple to make it work because of heat.
Yeah. Okay. Usually the warm-up time will take 2
minutes.
excuse me. Oh, excuse me. So it's auto warming up and
Yeah, one is ready, it tells you.
Okay. And LED UV doesn't have this warm-up requirement.
No need.
Okay.
It's
Almost immediately can use.
on demand. You call it on demand.
Okay. Yeah. Okay, when we say shutter UV system, meaning we can control the intensity?
No. There is simply a shutter inside that closes it right now.
Okay.
There's no light coming out. You can see that the light is on already.
Yeah.
But there's nothing coming out.
Okay.
So just as a shutter.
Okay.
So you can put your pass in.
Yeah. Oh, this one will be open from the side. Eh?
Open side.
From the side. Okay.
So once it's ready, the tell you it's ready.
Okay.
So now the question is, what should I do? Okay. This one, for this one, the intensity you can set from 50 to 100%.
Okay.
With this system. Okay, so now it's at 100%. Now this is timing. So this timing is for the shutter.
Okay.
The shutter. This is for shutter. So now it's set at 10 seconds. So let me go. Let me see the lights now.
Yeah. Okay. And it's UV filter plastic.
Yeah. This system, this one, I can tell honestly, is also, like I said earlier, this is an OEM from US.
Yeah.
Okay. Many years ago, we were OEM this. We are quite successful in selling this. And the reason why we decided not to continue next year is because everybody asked them for OEM. Okay. We have one company here try to butt in after we have been selling this, and they try to butt in by going to because some customer actually, when they see my customer, they actually ask them whether they have this or not, they don't have, so they try to come in and offer the same thing. So they also go back to the US company and ask whether they can sell their product. So unfortunately, the US company has a policy that they can sell. Okay? If they promise them certain unit. So we don't like it, so fine, you go ahead and sell, then you do our own. Simple. So then we also came across when in the exhibition, one Malaysian company also said name.
So ask them to
Also, we see no meaning like that. So that's the reason we don't continue. So we're going to do our own. So, but we are still selling it at this moment.
Okay.
So it's a very straightforward thing. So it's just that normally when you're successful, people just move on. Easy lah.
Okay.
We don't want to fight based on pricing.
Yes.
I don't want to go in sell something and the guy sells something $10 cheaper, $50 cheaper. It's a waste of time.
Okay. Does this have a safety features like when it is on, when someone actually accidentally open this, it will turn off?
Okay, the US only sell us this.
Okay.
They don't. This is our own. We do this.
Yeah.
Your feature they talk about, yes, is inbuilt into this.
Okay.
Not on this.
Yeah.
Okay. So it's inbuilt into this that works together with this.
Okay.
So we have a safety switch
Yeah.
that when you open, while this guy is on,
Yeah.
will automatically send a signal behind to close it.
Okay. Yeah.
There's only two menu, time and the intensity.
You can set password or something like this. You can set the what do you call it, the lighting to be dimmer, but not critical.
Okay. Okay.
So this is quite. Like I said, we sell it quite well. We sell all the way to China because Singapore Avago, there's Avago in Penang, there's Avago here. Singapore, Avago actually specified this equipment into one of their processes.
Okay.
So when they start out to China everywhere, so we start to sell to China
Okay.
because they have to get back the same thing.
Yeah. Okay.
So we sell quite a number of these.
OK，Ken 啊，你渣渣依開嗰個依個用手掣啦，我剔個 video 落嚟，等先嚇。
You want the light or you don't want the light?
哦，no without light is good. Yeah, OK。渣渣依掣個。After he actually put in right, then turn on the light.
Huh? It's a phone.
Oh yeah.
我跟住我咁樣
攞出嚟。OK，而家開個燈。
enter 嚟。
OK, good. Yeah. 就係刪。冇。OK， 你刪咗佢先。OK， 而家開。等陣啊。OK，我 switch。OK。Yeah。OK， 得。Thank you。
For sample program. So before we do anything, we can do some setting for jetting process. Actually, the jetting controller we can set how many dot you want to dispense on the same position, and then you can set the dispense time and pause or delay signal, and then how many pulse you want to dispense. After that, you just set apply, and then this one I set dispense time 0.01 millisecond, pulse time 50 millisecond. The number of pulse I set the 10. So if you manually pulse, it will do the 10 times of the dispense process.
But they are using the air to purge it out, right?
Air just for air process, we just give the string. No, dispensing process done by the jetting.
When they're doing the jetting, there's no air.
Yeah.
There's a plunger that's activated by diesel.
Okay.
So there's no air. Air is only to push the material inside.
Okay. So the use of this purging here means
This one for the manual.
Purging is for customer process. Normally, sometimes before the start of the operation.
they wish to
You want to put
discharge
something
out.
out, yeah.
Okay, that's all right. Okay, all right. Yes. Okay.
Let's see something,
Program.
No. Let's say I want to see some shooting.
Okay. So I do the sample program. Okay. Okay. To spend time 2 seconds, and then maybe I just put.
Bit longer, never mind. Not too short. Because too short, you need to do some optimization.
Okay. So to spend time 5 seconds shooting. And then I will do the last here. 应该有。
啊？
Yeah, actually you will see this one.
Can you see anything?
No, I think so. This one, if you will see this area, is. But I think so. Very.
You got paper?
Ah, no, no, no.
Yeah.
Yeah, this area.
But look at this jetting, they require some height.
Yeah,
If not,
It's, the advantage is supposed to be that the height is not critical.
Yeah.
Ah.
But this very near is better.
Huh?
Okay. Yeah. Hang on, one more time. Just take the video.
so they will define the height of what?
Hang on,
Either or so you just stated any height between is not really that respect.
Chatting.
You can set it above. Typically, of course, we want to set as close as possible. Just closer is more accurate.
Okay.
So, yeah. Okay. So this is, it goes out very fast because this is you are using solvent.
Yeah,
And
yes.
the reason why you solvent is really to clean.
Okay.
You material after you have to clean everything.
Yeah. Okay, can I no, I just wish to capture the movement.
Okay.
So you can see how fast it is. So this is the advantage.
Okay, can we move once more?